Hi everybody, welcome to another annual Distributed SQL Summit Asia, our user conference focused on the Asia Pacific region. Very excited to see so many of you come over today and to listen to what we have to say. And today's talk is all about AI. So I am Karthik Ranganathan, one of the co-founders and a CEO at Yugabyte. And it's been exciting to see both the usage of distributed SQL, AI, as well as the attendance in this conference steadily go up year over year. So welcome once again. And with that, let's jump right in. The theme for today's keynote is Hello from the year 2027. We thought it would be great and very interesting to go to the future, not too distant future, and look back on what the world looks like, and we picked the year 2027. So let's jump right in. This keynote is a panel. It's a panel with me, Karthik, as one of the panelists, and as a quick background, I've done various things over the years, but the most interesting and formative experience for me in starting Yugabyte and building a database company was at Meta, where we were, myself, my co-founder, a lot of engineers in our team, we helped build and open source databases such as Apache Cassandra, Apache HBase, as well as run database as a service at a pretty massive scale, helping us form the core of what we're bringing today to the industry. My other panelist, who you don't see with me, is the AI brain, TL5000. It's a cybernetic AI thought leader agent from the year 2027. TL5000 knows a lot, has indexed a lot of information, can answer a lot of questions, and has 3 arms, because 3 is better than 2. Okay, let's jump right in. In 2027, because of AI, if you're taking a sports analogy, the AI team, the team AI, beat the human team by 1,440 runs to 250 total, right? And this is the same as if you pick your sport of your choice. If you pick, say, if you watch soccer, well, that's like scoring 100 goals against 1 or 2 on the human side. And if you watch American football, that's like doing 500 points total with touchdowns and everything versus your 10 or 15 or 20 that the humans do, and so on and so forth, right? And you got to give it to AI. If it gets good at a thing, it gets really good at a thing, and it repeats it relentlessly, it learns from it, and it improves it. So we're here to talk about some of the core concepts of what it means if AI truly becomes pervasive in our infrastructure and software industry, right? And the sports analogy is just to take you out for a second, put it in a different space, and tell you what the world would look like if AI were to truly pervade the sports industry. Okay, so looking back from the year 2027, TL5000 tells us, here are some of the lessons learned in 2027. Here's how you would be thinking in 2027. AI will accelerate things beyond our imagination, and we are headed towards an era of exponential growth. Okay, that's point number 1. Now combine that with point 2, which is human mind, the human brain, is inherently not built for understanding and visualizing and working with exponential growth. Because we're so used to linear growth planning. We're so used to what comes one after the other and percentage improvements and so on and so forth. We think in terms of weeks, 2 weeks, sprints, years, quarters, and so on. We often tend to overestimate what we can do in a very short period of time. Like, you often think you can do more than what you can actually do today, this week, this year. And we completely underestimate what we can do in the longer term, say in the 2 to 3 year time window. And this was true even before exponential growth. Now it's going to be very, very, very true, and the gap's going to grow in the era of exponential growth. There's a saying, if you did something 10% better every day of the year, where would you be at the end of the year? And putting it mathematically, if you raise 1.1 to the power of 365. We all know 1 to the power of 365 is still 1. 1.1 to the power of 365 is like a quadrillion. It's 10 raised to 15. So it's a huge number, and it's something that we cannot process as humans. So don't try to process it. The key principle is don't build things to last. Build things that can rapidly iterate and evolve. So the principle changes to design for change. Okay, this is what TL5000 tells us. Now, what are some examples, right? What are some concrete things we can apply this to? The first thing is, we already know AI is coming. This is going to change into, here's how AI helps us, and that's then going to change into all your apps would now need to evolve and get updated, right? Now, contrast that on one side, changing all your apps and giving them the facelift, with LLM models constantly changing and new models coming in, and you can read pretty much every day in the news, some model beats some other model, a top 10 rank that changes. It's going to keep happening all the time, right? So if we are waiting for AI to stabilize, well, it's not. It's only going to accelerate in the rate at which it changes. Also think about dev and ops needing to do more with less. We see more and more companies that are really, really small that move very, very fast and are able to build a lot of applications. And this trend is another one that's going to accelerate. We talk about architectures for AI. We don't know if RAG is in or out. You hear like RAG, RIG, ROG, you hear so many things. You hear MCP and A2A. And what if I told you this is just the beginning, right? It's going to get much, much, much more intensified. You still have to scale your apps, because if your app succeeds, AI does its job. You reach a lot of users. You give the kind of user experience that the user has always dreamed of. Well, you would have to scale because there's an uptick in consumption, but you'd have to do it in seconds and minutes, not months and years, because there's no time. AI is ticking. Everything is faster. There's no time for manual performance tuning. Something else has to start tuning in real time and make sure that you're able to do your thing as you get the application running the way you want to as quickly as possible, and also keep costs under control. And ultimately, because of the proliferation of AI and the barrier to building applications dropping, the end user is going to have a hell of a time. It's a great experience for them. They can just switch apps left and right. If they don't like one, they can go to the other. So ultimately, the design principles of how these apps are built, run, deployed, operated is going to be the king, right? That's the economy that we're starting to look at. Data and operational design and infrastructure design principles are going to be really what make or break applications from 2027. Okay. You're probably thinking, what is TL5000 talking about? Is all this real or not? So let's jump right in. One of the biggest areas of impact we're going to see in 2027, one of the biggest changes, is how it changes the way we think about building software and operating it. You're probably familiar that there used to be a waterfall model and then an agile model. You do sprints in 2-week plans, so on and so forth, right? Pretty much all of that is going to go out the window, because statements like this, we shipped 350 apps this year, are going to become more and more and more common, right? It's what TL5000 tells us, and you're probably fair to ask, that's a whole bunch of BS. I don't believe that. Is that really, really true, right? This is what the industry estimates the growth of the software stack to become, right? Explosive growth in 2027. As you can see, the run up to 2027, we're at 2025, and we're seeing some size. 2026 is incrementally higher, and 2027, when we see AI not just capable of building apps, but being harnessed to really provide value and an impact, and value generation often comes with revenue, and once that cycle kicks in, more money is poured in, more apps get built, and so on and so forth. Once that kicks in, you can see that the amount of software getting built is already more than 3x what it is this year. And that just kicks off the race. It's by no means the end. 28 and 29 are much bigger. 2029 is almost 3 times what 2027 will be, and 2030 is enormously large. Now, if you're looking at the size between 2026 and 2030, that's just like in the next 4 years or so, that's a 5 to 10 times increase, right? And it's certainly not going to be done with 10 times more people, which means there's a huge amount of efficiency that needs to get built in and a fundamental revolution in the way we're starting to build and operate these applications. So, what strain in 2027 will everyone experience as a part of this explosion in building applications? Because if you're not doing it, someone else is. And so it just becomes important for the survival of companies, for the enterprises and the industry as a whole to adapt and evolve. Well, the first expectation is build and iterate at blinding speed, really, really quickly. And that means everything has to be a standard interface. You have to go and embrace the places where exponential innovation is happening, right? And for example, on the database side, as a database company, we can tell you that is Postgres. The Postgres ecosystem will save a lot of work having to be done, learning on the part of people, as well as innovation, because all of that is decentralized, it's happening everywhere. The second thing is there is a massive amount of re-architecting that needs to be done. Why? Because until 2026, there are a certain level of applications, set of applications that are the most business critical, and they are very important because we aren't exactly living in a non-digital economy. We are pretty digital ourselves right now, and this is going to flip and accelerate due to the law of exponential growth in 2027, which means your tech stack has to be completely modernized and be ready for flexibility, for ease of iteration and modernization. So it's not one big modernization, it is the start of continuous modernization. And the third thing, if you're doing this all right, well, you will expect to see more usage and more growth and more seasonality, like whatever your business requires. And that means whatever you do very quickly, like throw some resources at the problem, get it done quickly, is not going to last. Just the way exponential numbers build up, start slowly and then build up very big, your infrastructure build out needs to start slowly but firmly in order to reach the ability to be very agile and flexible and iterate quickly with your evolving needs. So, is that all? Not at all. There's the other aspect of the relentless improvement of AI itself. In the last year alone, we've seen an enormous leapfrog in the industry on what AI could do versus what it can do. And IDC predicts that over a third of the organizations will be doing experimental solutions, point-to-point solutions, will be doing AI, right, without knowing that what is the value or the ROI that they will derive from it. And this needs to change really fast. The AI is no longer experimental. It needs to be applied towards deriving value. And everyone's going to do a mad scramble for this. And that starts right at the building of the infrastructure layer, because the better the base, the faster you can iterate on top. The other big shift that's going on in the AI LLM space is that the economics are changing a lot. They're starting to change right now. And you can pretty much see the writing in the tea leaves that it's going to be very different and dynamic in 2027. There's a very, very famous quote going around, which I really like. LLMs are no longer venture capital subsidized, which means someone else is not paying for them. It's the end user starting to pay for them, which means that prices on AI-based companies are going up and are going to go up further. Things are no longer free. And people are thinking about how to monetize this to make this a sustainable part of our industry. And that means there has to be value creation, because no one's really going to pay for no value. The model themselves are changing into pay per crawl as opposed to a fixed cost, which means you're paying for data, and the more data you have, the better your AI gets, but the more you're paying to some of these providers for indexing your data. And just the way you decide when to rent a house versus own a house, or when to rent infrastructure versus own infrastructure, very, very similarly, you'd have to, at some point, start thinking about owning the stack rather than renting the stack, because rentals paid by amount of data that's being indexed is going to make the model really, really expensive. When you pay for convenience. When you pay for what you use, just pay for that. If you use it a lot, it gets very expensive. So does that mean you should actually use less? Or does that in fact mean you should rethink how you use it and think about using more if it really generates value? So we're going to see this fundamental shift. There's going to be a lot of protocol wars. I mean, there's another 3 or 4 letter acronym coming up almost every day, and it's going to get worse until the thing actually settles down. And ultimately, it's not which 3 or 4 letter acronym software piece that you take, as long as the APIs get standard. So standardization and open source will become super critical in this world because you do need interchangeable components, right? And so putting all this together, you have to think about not just flexibility, but also open standards, right? So these things become important when you peel the onion one level deeper. Now, that's not in isolation. There is a third force acting on things, like you have your software architecture, you have your LLM and AI space improvements. The third space is regulations and laws. You know, the governments are finding out that this is moving so fast, they have to keep more than just one eye on it. And so they're starting to restrict stuff. If an AI from one country trains the data of a citizen in another country on servers residing in a third country, who owns the data? If there's a lawsuit, who should expose the data to whom? So things are getting murkier, and that means the governments are doing their best to make sure they're able to enforce the required, like whatever they have to do to make sure that data regulations are upheld and the laws are defined before you uphold them. And so what does this mean? This means there's a lot of regulation on, you know, locality and data sovereignty, and you know what level of effort you have to do for row level data placement, for encryption, for making sure data generated by the personal data, identifiable data generated by people living in a certain region lives in that region. You know, models that are birthed in a certain region have to be used in that region or may not be used in a different region, so on and so forth. So ultimately, all of this will end up pointing to flexible and distributed architecture. So that's something we are going to have to embrace as an industry by 2027. So let's look at, you know, applications are built using an application lifecycle. And let's look at what changes here. So here's what application lifecycles looked like way back in the year 2025, before we had prepared for the exponential growth, right? You have a cloud native app that's born, and there's some innovation. You kind of figure out what you want to do, and you then kind of prove the innovation, the value that the app creates. And you go into a phase where you get ready for some growth, and then you deal with failures and outages because more people start to use them and it becomes an app with consequence. And then you get into a phase of even further growth, which is unplanned and planned scaling. Like sometimes you know what to predict, many times you don't. You have to be able to react. And then it goes back to building more innovation, and that cycle keeps continuing because you have to keep unlocking innovation, expanding and scaling out the innovation and getting it to reach the masses, and then kind of absorb the result of it reaching the masses and continue the cycle. Now, that has changed dramatically. Let's look at what? In 2027, here is a fundamental change to this application lifecycle. It goes from building a cloud-native app to building a Gen AI-ready cloud-native app. And the rest of the graph remains the same, except the speed at which you go from one state to the other is just accelerated 10 to 100 times, which means you're unlocking innovation, and as soon as you've unlocked it, you're already growing it and dealing with outages and preparing for scale, and you're back to innovating. So it's so fast, it happens almost simultaneously, and you do not get the time you did for each of these stages. Your innovation happens in a way accelerated fashion. Your rollout, your scaling, your figuring out your issues, everything happens so fast, it almost looks like they're meshed into a single box, right? Into a single state, because you're doing it all simultaneously all the time. So how do we do it in 2027? Well, you have a set of steps. You have your core application. You figure out what are the pieces that you want to enhance or accelerate using AI, and you prepare a knowledge base for it, whether it's from the app, outside the app, what have you, and then create a bunch of AI-based indexes, and then you put perhaps a an MCP server or a way for users to interact with it, like with humans to interact with applications, and APIs for other apps to or agents to interact with it, and you advertise capabilities, get the ecosystem working with you, and your refinement process almost immediately kicks in once you have the skeleton of this whole thing done, because you're preparing the knowledge base and you're improving the app happens almost at every step along the way and in parallel. So, what are the most important things here? As we said, you are preparing for flexibility and change. The stuff to the right, steps 3, 4, 5, 6, and so on, are about protocol and how it fits into the ecosystem. The stuff to the left, which is your core application, what is the data or the knowledge base that you want indexed, and how are you doing your AI indexes and your acceleration? That is the core, and that's what you'd have to focus on, because ultimately we're still at a state where this phase requires some human intervention, some human thought process. It's human assisted. So, with the principle that AI-powered apps are not built to last, rather designed for change, I think the most important thing to think about is how do you enforce this change really quickly and in a very scalable and easy manner. Now let's take it back like 30 years, 40 years in the past, when software development first was born. Well, you had a database, you put some data in it, and now let's say you wanted to access the data in a slightly different pattern. Like let's say you have a user database and you have user IDs and you want to look up a user by their email. What do? Well, you go to the database and you simply create an index, a secondary index, and you look up by the index. The creation of the index, maintaining it and building it in the background, making sure it's consistent with the foreground application, and switching to use it at the right time, as well as being able to modify this index or even drop it if it's useless. The entire life cycle is abstracted away as infrastructure. It's handled by the database. Your AI data sets and your AI functionality has to be the same. If anything, it has to be even more ready to be handled in the background efficiently by other processes. So, this is something that as Yugabyte DB, we are super proud of innovating on. What we do is we offer the PG Vector standard Postgres interface, adhering to open source standards, very, very easy to use and well integrated into the ecosystem, but with the critical capability of being able to scale to add multiple indexes, a lot of vector dimensions, as well as hold not just your original application data, but also your document chunks, all in a single place. So our goal is to streamline not just your data and your application usage, but your whole application lifecycle, so you don't have to build an infrastructure, instead rely on the database to manage and index. So your indexes, your AI data is just an Gen AI based index, right? It makes it that simple. So one of the important things, whether you choose Yugabyte DB or Postgres in general, think about the pros and cons of choosing a specialized database for vector indexing versus a general purpose database like a Yugabyte DB or Postgres. Really think about it, because is the goal you're trying to solve the little bit of differential value that a vector database gives, which is fast getting commoditized and the databases like Postgres and PG Vector are catching up? Or is the real value you're building to the flexibility to change in place? Because if you're just dealing with your AI indexes as another index, you don't have to do any lifting. You don't have to set up infrastructure. You'll be that much faster in that loop of software development in the Gen AI era. Okay, the other big change that's going on is your architecture for the RAG application itself. There's ROG, there's RIG, there's RAG. Retrieval optimized generation or retrieval augmented generation. So are you going to generate a whole bunch of stuff and then figure out what to do at the retrieval time? Or are you making sure that whatever you have generated is really, really good at the query time, so you're very optimal, right? So there's different approaches to it, but ultimately there are a huge class of applications where you want to lean on the database and to make sure that your cost is under control, and you want the response times to be relatively low. You want quick response times. And so your users in 2027 will expect this. They will expect the cost to be affordable as well as the latency to be low. And so it's more important to focus on your business data and your business value that you can unlock more than the amount of architecture that you're building. And this inherently will require a multimodal approach, like use the data model that's best fit for your service. And that in turn will require Gen AI capabilities, which are best served if they are a part of that database itself. The other thing we talked about, in addition to everything we addressed above in the software development lifecycle itself, is the importance of the data layer and also of open standards. And if you apply that, if you apply open standards, open source to the data layer, it's pretty clear that Postgres is evolving as the database for modern applications. Well, TL5000 says Postgres is the 5th most common baby name in 2027. I guess they started naming the kids of agents and other agentic applications as babies, but nevertheless, Postgres, it's fair to say, is pretty damn common and is going to be the standard, in 2027. So, if you look right now, that's where Postgres stands. Like right now, it's at 48% of developers voted that Postgres is the most popular database, is their database of choice for the 2nd year in a row. And remember, when you apply exponential acceleration to this, the numbers will shift dramatically in just a couple of years, right? So Postgres is becoming a de facto, is becoming super critical as a piece to the AI infrastructure, and this is one of the things at Yugabyte DB that guides our roadmap. So this chart in front of you shows the Postgres compatibility as tested by a third party of various different databases. And we're climbing up, and our aim is to get to almost 100%. So that's the place where we're headed. Right now we're at a 85%, pretty close to where say an Amazon Aurora or a Google Alloy DB is, but with the flexibility of being able to scale and geographically distribute data. But, in the cloud native world, Postgres is an interface. Postgres handles data. Postgres gives you a set of, features that you can use to build your application. However, there are a bunch of non-functional requirements that become super important, like how cloud native is the database itself, like in its ability to be able to quickly scale, to deal with resilience, and so on and so forth. How enterprise grade is it, like in its ability to handle variances in cloud infrastructure, like gray failures, its ability to troubleshoot very quickly, security that it offers out of the box, as well as how AI ready is it in being able to stitch all of these things, including the ecosystem integrations and security and observability and performance for AI and all of that stuff. Everything needs to converge into a box. And these are some of the areas that we're looking at with Yugabyte DB, as I'm sure are a lot of others, but in general, adding to the Postgres ecosystem. Think of the industry, the database industry, as working in 2 axes, and this is more for the transactional databases. On the y-axis is just how Postgres can you be, and that helps unlock the speed of building applications and the power of Gen AI that you can bring to the table. And on the x-axis is how cloud native is a database in being able to bring that Postgres innovation into the cloud native, AI native era, right? And so Yugabyte DB was designed to sit at very cloud native and highly Postgres compatible, so we can keep bringing Postgres innovations to the cloud and add cloud innovations to become Postgres compatible. So it's a two-way innovation, kind of roadmap for us, so to speak. If you look at the enterprise grade, the second thing we talked about, we did talk a lot about AI. If you look at the enterprise grade, there are a lot of features that enterprises need, and that have been handled by the traditional commercial databases, but they need this in the cloud native form factor. So if you're going up and deploying it in containers or in a public cloud or on commodity hardware, you need a lot of these things. How do you do availability and DR for the modern topologies and for the modern way of architecting, regions and data centers? Or what do you do for online upgrades and downgrades? Because remember, you may be doing an upgrade, but AI is accelerating your application to be able to reach more users. And if it's the wrong thing to do, well, you roll it back and kind of figure out what to do rather than take the downtime to figure out, because time is money, quite literally, in the world of AI, right? And similarly for blue-green deployments, to make sure your data is safe, or security and SecOps, or your change data capture, which flows the data into other ecosystems, or connection pooling and how many connections that you handle, which is a Postgres weakness, but it's something that becomes super critical in the world of AI, as more and more agents will wake up and connect to your database, and there simply will be no time to react to it. You can put a connection pooler in front. It's just going to make things more complicated and slow you down, because you now need to configure the connection pooler and with the right set of parameters and so on and so forth. Or things like observability and perf tuning, or even multi-tenancy. The important takeaway here is that in the old world, it used to be each of these are a separate line item, and you needed these capabilities. In the new world with AI, everything converges together and is acting at the same time. For example, if you have an issue with your software upgrade, your performance observing and troubleshooting capability should be quickly able to detect it and then tell the agent that upgraded your software to downgrade it back, while it really does a deeper troubleshooting, because it's important to get these type of orchestrations in place. So we talked about how Postgres was becoming fundamental to the AI data layer. Now let's talk about the cloud native aspect of Postgres, specifically, scale and ultra resilience. Well, TL5000 says there is such a thing as vibe coding, but there's no such thing as vibe resilience, which means that you cannot create your resilience on the fly. You have to carefully plan it ahead of time, right? And these would be some of the harder, slower, upfront fundamentals we have to lay as groundwork in order to be able to accelerate using AI. So why is it still important in 2027? Well, if you look at statistics, 53% of the companies do not believe they're as resilient as they need to be, because as digitization is starting to increase, as everything is increasingly going online, the stakes are getting higher, and the need for uptime is now directly translating into money and brand and stickiness and trust in the eyes of users and so on, right? An hour of downtime is about $100K for 98% of the orgs, and it's a lot higher the bigger the organization, the larger the use case. And 88% of the people think we'll see a huge outage in the next 12 months, like a major outage that brings down a big fraction of the internet down to its knees. So these are the stakes that we're playing with in this modern era. So resilience above everything else takes a front seat. When you think about resilience in the old world, it would be a machine goes down, let's replace the machine. A machine goes down, can I switch over the traffic to another machine while another machine goes down? Well, another machine replaces it. Great. But in the modern era, resilience or ultra resilience is not just that. That's just the first part where a machine goes down. That's inside a single region. What happens if your entire region goes down? And remember, 88% of the people think an entire region or more will go down in the next 12 months. And the more we put the way probability works, the more issues we're going to see. The more apps that go digital, the more probability of seeing issues come up. What about if somebody accidentally drops a table by mistake in production? What happens if your application had a software bug that corrupted your data and you needed to roll it back? What about doing a software upgrade or a security patch because there was a new issue, a vulnerability found, and you need to upgrade your OS? Will that impact your uptime? And because the users really don't care that we're fixing a security bug, they just want everything to work, and AI, remember, is accelerating everything. What about if there's no outright failure, but one of the components is slow or is not responding well, called gray failure? And finally, what about if AI really succeeds and everybody logs in to see something at the same instant for like an hour, and your traffic takes a 10 or 100 times spike during this time? Well, all of these are real scenarios, and they work together, right? All of these, like your peak event can unlock a gray failure, which can unlock like your need for in-region or cross-region resilience. They all work together. So it's important to note that we are entering a new era of ultra-resilience, and what we have built so far isn't sufficient. So The business value that we unlock with laying out some of these architectures up front, you can make your customers happier. They just don't have to think about anything going down or become slow. You will have high availability, so all your transactions, everything that's happening, happen 24/7. You don't need as many people to run your operations, and you can do so in a more relaxed manner because you know that something's got your back and it's always working. You can automate data protection things like backups. You can go multi-cloud and reduce the risk of exposure to a single cloud, whether it's for cost purposes or for availability purposes, because the probability of the same issue hitting two different cloud providers is really, really low. And your support costs, your technical depth, your upgrade stress, your stress around the peak events and upgrades, everything goes down, and it fosters innovation, agility, and ability to create more value. So we do have a white paper that we worked on with a lot of the largest enterprises in the world, and just reach out to us if you're interested. And what we're really trying to do is to avoid vibe resilience, where you kind of patch and fix things as they come up. It is better to think about ultra resilience instead, and design it the right way up front. And remember, it doesn't necessarily mean it's more time or money. It's just making thoughtful, informed decisions ahead of time. You should expect in 2027 more and more and more tables, more data, more structures, more complex queries. So your data horizontal scalability as a construct becomes very critical to your scalability aspect, in addition to being able to ensure resilience. So your data that's in this example living across 3 nodes must fundamentally be able to scale to a 4th node and a 5th node and a 6th node, and come back to 3 nodes when you don't need it, in order to be able to handle your peaks, your spikes, your generic growth through AI, and so on and so forth. Another of those lessons that TL5000 talked about was privacy data regulations. Pretty much assume in 2027 that almost every country or group of countries, geographic region, will have their own data laws, data residency, data compliance laws, and LLM laws. And this is because, as we said, governments and legal bodies have to really understand and lay out a clear set of guidelines for what it means to be in violation. Is it the LLM that is at fault? Is it the data provider and the hoster that's at fault? Is it the person running it from a different country that's at fault? So as we get more and more entities collaborating to unlock value, we would need more and more finer-grained differentiated set of laws, right? And so it is important to think about distributed systems as a whole, and specifically in our case, distributed data and AI processing from this point of view. Because you could have the same application which will be subject to different laws and different sets of libraries and open source components and stacks in different geographic regions. So a single app needs to look as uniform as possible, with switchable components and ability to place data in different locations to be able to function in the modern world that we're going towards. So ability to partition your tables and place partitions in different locations, partition your whole database, be able to put different LLMs or different set of clouds in different locations. All of this will become critical functionality and will start to become the underpinning of modern architecture. Okay, so we talked about a lot of stuff. We talked about how software development lifecycle is going to change. We talked about the data layer, open source and open standards. We talked about things like observability and enterprise grade features. We also talked about privacy regulations, compliance, and so on. So let's ask TL5000. So how do you use this information right now? So great, 2027 looks a certain way. We get an idea. What do we do right now? So here's what TL5000 says. Well, the first thing is AI is all about ecosystem. So embrace the ecosystem, but make sure that it's open standards and switchable components. You will have a proliferation of newer things come up, and some things that rise to the very top and some things that sink to the bottom. So make sure you're ready for this life cycle. Make sure that the different components in the stack are truly built with standardization of AI across the board, because there's a lot of discussion on proprietary AI, open source AI. the gap between them is already diminishing, and you can see a not so distant world where it diminishes even further. So what becomes important is switchability for all of the reasons we talked about above. The second thing is, embrace, once again, with Yugabyte DB, we have an MCP server, and we strongly believe that's going to be a huge way, if not the only way, there's going to be a big way in which people interact with applications. So gone are the days when you actually have to see a UI and do stuff. You just talk to your applications, whether it's by typing or by actually talking, right? And so you got to bridge the gap between the application, the way the user wants to interact, and the data. And at Yugabyte DB, we have our MCP server, Model Context Protocol server, which will help you do that in a jiffy, right? And there's a lot of them, and it's based on Postgres, so it's pretty standard. And if it's, it does have the ability for you to switch and standardize if you need to at a future stage. This also leads to exploration and unlocking new ideas without having to learn SQL, to learn coding, so on and so forth, right? And it provides a secure and extensible foundation for LLM-enhanced applications. We're actually taking this a lot further in the way we're thinking about it. We want the entire life cycle as it relates to data for your AI and RAG pipelines to get simplified. So this is something that we're working towards, but the MCP server is definitely a step in that direction. So if you're interested, do reach out to us. Agentic AI for ops. We talked about how the enterprise side of the features are all converging, and ultimately it could be a problem with your day 2 operations, it could be a problem with an upgrade, it could be a problem with a query that was written by a developer, or an outage in a cloud infrastructure. To the business, it doesn't matter. So it is very important in the new world to build applications that are cross-cutting, that are more oriented towards unlocking the value and like keeping up the SLAs rather than traditional, the engineering lines and product lines across which they function. So, our performance advisor is an agentic application that hits not just the ops, it's for ops, but it hits not just the ops, it also hits the developers, right? It's a single place to go to consume how do you troubleshoot and how do you improve performance of your applications by looking at anomalies, by looking at best practices, by looking at deviations from best practices as early in the cycle as when you're starting to build the first line of code. And it works all the way to observing your patterns and your increase in usage and trying to predict when you will hit issues. And once you hit an issue, try to find out where in your stack could the issue lie in, right? So this is something that's coming out, and we are running a program to take some of our earliest customers to work with. This is something that's ready. If you're interested, once again, do reach out. But this is the shift that we're trying to implement with this innovative product. You go from, can you tell me quickly what went wrong in my deployment, which is the traditional thinking when you try to troubleshoot, to can you tell me can you fix something before it happens, or tell me something would happen before it does? Can you predict the chance of something wrong going to happen ahead of time, right? And under that, like if you look at the shift in the mindset, it goes from find out after I deploy to hook in right at the development time and tell my developers, if you write this and it runs at that scale, you're going to have an issue somewhere else downstream. Or detect and resolve an issue changes to predict and prevent using AI. Or like design, plan, and figure out which cloud and infrastructure you're going to use ahead of time changes to continuously look at my deployment and keep changing it and optimizing it to put it in the right cloud, in the right topology as my application evolves. So it's a continuous process. Troubleshooting and runbooks are very important. Changes to just auto-remediate, find out the issue in real time and figure out how to troubleshoot, what does the runbook say, but as code, and go call those APIs and go make those changes so that I'm able to run more efficiently, and humans will be in the loop to assist all of these things as opposed to perform them. So this is a traditional view of how a performance report would look like, and what we're enhancing it with is looking at it, give me the context of what went wrong and what do I do in order to improve the performance, and if you can do it, just do it. Like I will set a policy of you telling me I want to do it, or you just automatically do it yourself. So big picture, remember this diagram that we talked about, 2027 software lifecycle? It's about speed. It's about agility. It's about being able to evolve into whatever components need to change to be able to go through the cycle on the right very, very, very quickly, because there's a lot of growth, there's a lot of outages, and there's a lot of planned and unplanned scaling, and a heck of a lot of innovation that we're going to see. And it's all going to happen really quickly with no time to go one way or the other, no time to react as humans. So we need agents and models and AI and software to be able to do it instead of us. Okay, so what's ready now and not in 2027 is, and what you should be doing is thinking about how you evolve your architecture to get ready for 2027. So we've extended the PG vector interface, as I said, with native vector search by using usearch and other search libraries. And it's fully Postgres compatible. It works exactly like PG vector, but it supports a heck of a lot of features. We can add more and more libraries into it. It's extensible and scalable with auto sharding and like ability to replicate it for resilience, and also geo-distributed. So you're able to take care of all those compliance laws, getting your data closer to users for a better performance, lower latency, so on and so forth. So a lot of value coming together. If you're interested in trying out vector search on Yugabyte DB, reach out to us. We're doing a lot more innovation, as I said here, by taking care of as much of your data-facing, AI pipeline and lifecycle as possible. So a lot of innovation going. If you want to be a part of that journey, definitely reach out. Once again, Yugabyte DB is an AI-ready multimodal database. It's Postgres-based for business-critical applications, and many of our users, some of the biggest companies in the world, use it to run some of their most business-critical workloads. And if you want to give it a spin, it's completely open source with a standard API, like we talked about. Great. So that brings us to the end of this keynote. But this is not the end. This is the beginning of our Distributed SQL Summit Asia. A lot of interesting talks with really good speakers. I would encourage you to go and look at all of them. I'm just going to talk about a couple of them here. We're like KFinTech. They're going to talk about how to deliver always-on financial services. And as you know, financial services are all about precision, speed, about honoring the transaction. So it's about real transactions, real money in one of the largest digital economies. So do take a look. There's Boltic, scaling globally to build multi-region SaaS applications for millions of people with Yugabyte DB. So this is a SaaS global application. Like how HelpShift accelerated their growth by migrating to Yugabyte DB. So this is growth acceleration and along those lines. There is the future of payments with MindGate and how they're powering the future. There's customer-centric real-time operations with our OCBC bank. There's also how we power AI-powered fraud detection. There's database migration improvements, a lot of cutting-edge stuff going on that we're doing to modernize workloads from other databases into Yugabyte DB. And there's also how geo-distributed deployments really give you flexibility. And these are just a snapshot. There's a lot more of interesting sessions, folks. So the idea behind the DSS, the Distributed SQL Summit, is always to share, to learn, and to think about thought leadership and improvements, be in touch with the improvements in the industry. So I wish you guys a very happy DSS. Thank you.